The next topic is energy band theory. So already we saw electrons revolve around nucleus in different shells. So first shell, second shell, third shell, like that. So the final shell is valence shell. That is where valence electrons will revolve. But this is a case of a single atom. This is a case of single atom. So this is 2 electrons, 8, 4. I am considering silicon here. So this is a single atom. But if you consider a solid, in a solid, atoms are brought close together. That is, a solid is formed with atoms like this. Okay, so here atoms are brought close together. So this is a single atom. So in such a case, what happens is the outer shell electrons, that is valence electrons, are shared by more than one atom. So these electrons come under the influence of forces from other atoms too. So what happens is the valence electrons are shared by forming a bond with the valence electrons of adjacent atom. That is, this is a single atom, this is a single atom. So in valence electrons of this atom and valence electrons of this atom, they will form a bond. So the valence electrons form this type of bonds are called covalent bonds. Covalent bonds. So one more important point is each valence shell has a energy level. Suppose energy level. Similarly, this atom has some energy level. This atom valence shell. So all these valence shell energy levels are merged together and they will form a energy band. That is valence shell of first atom, valence shell of second atom, valence shell of third atom. So all the energy levels of all valence shells combine together and they will form a energy band. So this energy band, like this is a energy band. This energy band is because of valence shells of all atoms. Similarly, energy levels of various electrons present in the first shell, second shell, etc. also merge together and to form various energy bands. So the energy bands are like this, like this. So this is a energy band. This is because of first shell electrons of all atoms. This is energy band due to second shell electrons. Like this, this is the energy band due to valence shell electrons. Valence shell electrons of all atoms. So like this energy bands will form. So we have so many energy bands, but out of all energy bands, 3 bands are most important. They are valence band, conduction band, third one is forbidden band. Forbidden band or forbidden gap. So these are the most important energy bands to understand the behavior of solids. So valence band we know. So valence band is a energy band formed due to merging of energy levels associated with the valence electrons, that is electrons in the last shell. So that is a valence band. Now what is conduction band? That is, suppose this is a valence shell electrons. In normal condition, what I must say is the valence electrons form covalent bonds with the other atoms like this. Covalent bonds with other atoms. And they are not free. Because of this bond, they are not free. So, but when some energy is given to these electrons or some energy is applied to these electrons, then they become free. So I am applying some energy to these electrons, so they will become free. That is covalent bond. They just break the bond and they will come out. So they become free. So the energy band formed due to merging of energy levels associated with the free electrons is called conduction band. That is, valence shell has an energy level. By giving energy, they are just out of the valence shell. That is, they are going to some higher energy level. So, where electron will become free. So, the energy band formed due to merging of energy levels associated with the free electrons is called a conduction band. So, under normal condition, conduction band is empty. That is, no free electrons exist under normal conditions. Once energy is given to the electrons, the valence electrons jump from valence band to conduction band and become free. So something like this. Suppose this is valence band. This is valence band where electrons exist. Suppose if I apply some energy to these valence band electrons, they will become free and they will move to conduction band. So in conduction band, free electrons exist and which are due to which all electrical or all chemical reactions possible. The third one is forbidden band. That is, while jumping from valence band to conduction band, the electrons have to cross an energy gap. The electrons have to cross an energy gap. So this energy gap which is present between conduction band and valence band is called forbidden band or forbidden gap. So how we can define is the energy gap which is presented between conduction band and the valence band is called forbidden band or forbidden gap. So this is very important band. So based on this forbidden band only we can classify the materials. That is, the energy what we are applying to the valence band must be greater than the energy level of forbidden gap. Then only the electrons will move to conduction band. One more important point is there is no electrons in the forbidden gap. That is, the electrons cannot exist in forbidden gap. That is, electrons may exist either in valence band or conduction band, but no electron will exist in forbidden gap, which is very important point. The next one is unit of energy. So here we are talking about energy bands. What is the unit of this energy? In what units we measure the energy? Generally, energy is measured in joules. But here the energy associated with this energy band is, if you measure in joules, joule is a very big quantity. So the energy associated with the energy bands is very less. So there is a special unit or particular unit to measure the energy of the bands. So the energy is the measured unit is electron volts. Electron volt. So 1 electron volt is equal to 1.6 into 10 power minus 19 joules, which is very less compared to joule, 1 joule. Okay. We will measure in electron volts. How we can define a electron volt is 1 electron volt is defined as the energy required by an electron to fall through a potential of 1 volt. This is the definition of electron volt. 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Now, classification of materials. So how we can classify materials? So this is based on energy band theory. Based on energy band theory, how we can classify materials is like this. I am having a valence band. So this is a conduction band. So this valence band I am indicating like this, conduction band with the horizontal lines. So if conduction band also lies in valence band, that is merging, and valence band also lies in conduction band. Okay, that is there is no forbidden gap. This means there is no forbidden gap. That is no forbidden gap. That is overlapping of valence and conduction band. Overlapping of valence and conduction band. So if this is the case, the materials are classified as conductors. That is, there is no forbidden gap, then that is there is no need to apply any energy in conductors. More free electrons exist in conductors. That's why conductivity is more in conductors. Suppose this is conduction band, this is valence band, the forbidden gap, this is forbidden gap. So this is a large forbidden band, large forbidden gap. That is, there is a highest, more energy level between valence band and conduction band. Then the materials are classified insulators. That is, we need to apply more energy for valence band electrons so that they can move to conduction band. Similarly, another category is, so this is a valence band, conduction band, small forbidden gap. small forbidden bank. So the gap is less. If the gap is less, then the materials are classified as semiconductors. Okay. Generally the forbidden energy level is defined by Eg. Here Eg is equal to 0. Here Eg is very very greater. Have some more energy level. Here Eg is very less value. So like this, based on this forbidden energy gap, we can classify the materials into three types: conductors, insulators, semiconductors. Conductors, there is no forbidden gap. Insulators, large forbidden gap. Semiconductors, small forbidden gap.